Hello guys, in today's class I'm going to provide solution to this one of the difficult quadratic equations. Okay, so it takes a very high level of reasoning for someone to solve this question correctly. Okay, so this is what we are going to do. When you look at this equation, this is a quadratic equation and this is another quadratic equation. Let me just say this is a quadratic expression while this is another expression, and this is equals to 1. Okay, so one thing you should know that here, let's assume what we have here is a raised to the power of b equals 1. Okay, what are the possible values of b or a for this to be 1? So this is exactly what we are going to use here. Okay, once you know the cases or the possibility of you getting 1 here, then you are good to go. Is that taken? So with what we have here now, like I've said, a raised to the power of b equals 1. So first thing we have to look at here is that, okay, case 1. So for a raised to the power of b to be 1, so that means a raised to the power of b can be written as a raised to the power of 0. Okay, then this implies that b equals 0. This is case 1. Okay, so when you apply this case 1, it means that in the place of a, we have a to be x squared minus 11x plus 29. Then we assume b to be 6x squared plus x minus 2. So since a raised to the power of b equals a raised to the power of 0 will give us 1, it implies that b equals 0. So that is 6x squared plus x minus 2 equals 0. Alright, so and to solve this, we need product of minus 12 sum of 1. So you could make use of 4x then minus 3x minus 2 equals 0. And of course this can be factorized. Let me take 6x squared and minus 3x. So we could factorize 3x, then left with 2x minus 1, then 4x and minus 2. 2 can be factorized, then you have 2x minus 1 equals 0. Okay, and this is going to give us 2x minus 1 and 3x plus 2 by the time we factorize 2x minus 1, so equals 0. So we therefore obtain x equals 1 over 2 or x equals minus 2 over 3. Okay, so it means that these are the values of x that will make b to be what? To be 0. Okay, that's the first case. Now the second case we're going to consider here, which is case 2. Yes, we've considered when a equals 0. This will also give us 1. Okay, ab equals 1. What if we consider a raised to the power of b equals 1 raised to the power of b? Okay, a raised to the power of b equals 1 raised to the power of b. It means that 1 raised to the power of any number will actually remain as 1. Okay, and for that reason, this implies that a equals 1. Okay, for a to be 1, now remember we have it here that x squared a is x squared minus 11x plus 29. So it means that x squared minus 11x plus 29 equals 1. Okay, by implication you obtain x squared minus 11x plus 28 equals 0. So next thing, we need product of 28 sum of minus 11. So you could make use of 4 and 7. Okay, minus 4 minus 7. So x minus 4, x minus 7 equals 0. So it makes x equals 4 and x equals 7. So when x equals 4 and when x equals 7, you're going to obtain a raised to the power of b to be 1. So that's the second case. Yeah, a lot of students stop here, but that's not right. So this is not the only case for you to get 1. So there's another case where we call that to be case 3. Remember what we are considering is a to the power of b equals 1. Okay, we've considered when a raised to the power of 0 equals 1. Then we've considered 1 raised to the power of b equals 1. So what we're going to consider here now is, what if you have minus 1 raised to the power of b? Yes, minus 1 raised to the power of b can actually be 1 only if b is even. If b is even, it means that negative raised to the power of even number will give us what? Positive number. So minus 1 raised to the power of an even number will be even, it will be 1. Okay, so this is the last case we're going to consider, but mind you, we emphasize on b is even. So it means that when we are going to solve we only consider the even number that will satisfy this. Okay, not even results, but the even number that's going to satisfy this equation. Okay, so since a raised to the power of b equals minus 1 raised to the power of b, it also means a equals minus 1. Now we have x squared minus 11x plus 29 equals minus 1. So x squared minus 11x plus 30 equals 0. Now can this be factorized? Product of 30 sum of minus 11. Yeah, could make use of minus 5 and minus 6. Okay, so x minus 5 and x minus 6 equals 0. So it makes x equals 5 and x equals 6. Okay, so what you are saying here, please, this place is very technical, so you have to be very careful here. We said if b is even, we are not talking about the value of x. We emphasize on the value of b, not the value of x. So to get b, okay, we already assume b to be what? From the beginning we assume b to be 6x squared plus x minus 2. Okay, so since b is 6x squared plus x minus 2, so we check for the value of x that we obtained here, 5 and 6. Which of the values of x will make this to be even? All right. So we consider when x is 5. When x is 5, we have plus 5 minus 2. So b is 6 times 5 squared, that will give us 25, then plus 3. So 6 times 25, that will give us even number. That will be 150. 150 plus 3, that is 153. 153, and this is odd, so we're going to consider, we are not going to use x to be 5. So next thing we have to use is x equals 6. When x equals 6, then we have b to be 6 times 6 squared plus 6 minus 2. All right, so b is going to be 6 times 36 plus 6 minus 2, that's 4. And of course this is even, so it means that the value of x we're going to consider here is 6. So finally, now the values of x that will satisfy this given equation, okay, we have 1 over 2 minus 2 over 3, then 4, 7 and 6. So these 3 values, or these 5 values, are going to satisfy the given equation. So this should be outside. You are not going to use x equals 5. All right, and that is the solution to the to that given problem. All right, so don't forget to like, comment and subscribe so that you'll be notified whenever I release a new video. Thank you.